Good morning and welcome to my class. I'm Ms. Vandana Gupta, Assistant Professor of Mathematics. See, we have started with Unit 1 of Mathematics, that is functions, derivatives, and their applications. So we have already finished functions and derivatives. We have solved many problems also on that. And we had started with the applications of derivatives. In the applications of derivatives also, three applications we have seen. First was how to find out the marginal cost. So once again, let us recall what is marginal cost. As you know that the cost is a function of number of items produced. So cost depends upon number of items produced. So C is a function of X. So as you change X, number of items produced changes, cost will also change. So the rate of change of cost with respect to the number of items produced, that is called as a marginal cost. Now, what is the meaning of rate of change in terms of mathematics? It is the derivative. So marginal cost is derivative of C with respect to X. So if you are the first application which we have seen, we have solved some problems also on that. Find the marginal cost at a given point. Then marginal revenue. You know that revenue depends upon the demand of the item, correct? So revenue changes when the demand changes. So the rate at which the revenue changes with respect to the demand, which is called as a marginal revenue. And in terms of mathematics, that is nothing but derivative of revenue with respect to demand. So marginal revenue is derivative of revenue with respect to demand. And we have solved some problems in the last class where the revenue was given to you and we have find out the marginal revenue at a given point. Then the third application, which I think in the last lecture only we saw, how to find out the elasticity of demand. So elasticity of demand, which we denote by eta, which is a Greek symbol eta, it is given by minus P divided by D into derivative of D with respect to P. And we have solved some problems where we have calculated the elasticity of demand at a given price. Okay. So this much we have seen in the last class. So today we are going to see another application of derivative, which is called as Maxima Minima. These are also called as optimization problems. Optimum is a common word used for maxima or minima. So another application of derivative that is called optimization problems. That is to find maxima and minima of a given function. What is meant by maxima? Suppose you have got a function y equal to f of x. What is the maximum value of this function? And at which point that maximum is occurring? That is called as a maximum value and the maxima at that point. Similarly, at what point this function is taking the minimum value? That is called the minima. And what is the minimum value of the function? Okay, so we are going to see that today. By this can be found out with the help of derivative. So it is one of the most important application of derivative. But before we proceed for that, let me introduce you with what is second order derivative means. Okay. Now, as you know that cost is what? Cost is a function of number of items produced. Cost depends upon number of items produced. And in any organization, in any factory or any, what you can say, organization, the aim is to minimize the cost of production, correct? So the aim is always to minimize the cost of production, and profit always would like to have maximum profit. So the aim is what? To minimize the cost. To minimize the cost and maximize the profit. We are talking about the functions in economics and commerce. Okay. So we know that in any factory or in any organization, the aim is what? to minimize the cost. So we are going to see how to minimize the cost and how to maximize the profit. Profit, everybody would like to have more, correct? So how to maximize the profit? So these are the two aims of any organization. Let us see how will we do that with the help of derivative. Okay. So before I actually give you the step-by-step method to find the maxima and minima value of the function, let me introduce you with what is called as second order derivative. Okay. So let us see the concept of second order derivative of a function. So second order of a function y, which is a function of x. So y is f of x. Y is a function of x. That means the value of y depends upon x. You can express y in terms of x. For example, y is equal to x square. It's a function of x. Y is equal to x minus 5. It's a function of x. Y is expressed in terms of x. जैसे कि cost is a function of x. So cost is expressed as a function of number of items produced. So if you are given a function of x, what is meant by second order derivative of y? Okay. So you all are aware of the first order derivative. It is the rate of change of y with respect to x. That is called the first order derivative. What is second order derivative of y? So second order derivative of the function y is denoted by, when I'm talking about the second order, I will put a square here. So it is d square y by dx square. And we are finding the second order derivative with respect to x. So this is the notation. See, first order, what was the notation? dy by ds. Correct? This was the first order derivative. Second order mein, we will put the square here, d square. And we read it as d square y by dx square. Okay. So this is the notation for the second order derivative of the function y. Okay. How it is calculated? So it is denoted by d square y by dx square and is given by, how do you give this? Second order derivative of y with respect to x is the derivative of the first order. Look at this. How do you calculate the second order derivative of any function? You take the derivative of its first order. Okay, that is what is the second order derivative. I'll give you, explain you this with the help of a simple example. Let us take an example. Let us say y is equal to x square. It's a very simple example. Y is a function of x. Okay. Find its second order derivative. This is what is my question. Find second order derivative of y. How will I do that? So according to my definition, what is second order derivative? It is the derivative of the first order. So I need to first find out the first order derivative. So let us first find out the first order derivative. That is dy by dx. This is called as the first order. This is equal to derivative of y. Y means x square. What is derivative of x square? 2 into x raised to 2 minus 1. You know this formula of derivative. All the formulae you should know. Derivative of x to the power n is n into x raised to n minus 1. This formula I'm using here. The power of x is 2, n is equal to 2. So 2 into x raised to 2 minus 1, which will give me 2x. Okay. That means the first order derivative of this function y is 2x. I have to now find out the second order derivative. As per my definition, what is the second order derivative? It is the derivative of the first order. It is the derivative of the first order. What is the first order we got here? We got here first order as 2x. So derivative of 2x. Okay. Now this 2 is a constant. Use the scalar multiplication rule. So 2 will be taken out and derivative of x. And derivative of x with respect to x is 1. So it is 2. So that means the second order derivative of this function is 2. Okay. So what we have got? The second order derivative of this function is equal to, okay, I hope you have understood. Basically, to find the second order derivative, you first find the first order derivative. So we have found out the first order derivative, that is 2x. Again, you take the derivative of this first order. That will be the second order. So derivative of the first order, that is derivative of 2x, which is 2. So the second order derivative of this function x square is coming as 2. Okay. We'll take more examples to illustrate this. Take another problem. Let y is equal to x raised to 5. Find second order derivative of y. Find second order derivative of y. Okay. So first of all, we will find out the first order derivative of y. The first order of derivative of y. Y means x raised to 5. What is its derivative? 5 into x raised to 5 minus 1. So it is 5x raised to 4. Okay. Now you want to find out the second order derivative. What is second order derivative? It is the derivative of the first order. What is first order derivative? You got 5x raised to 4. So 5x raised to 4. How will you find out this? This 5 is a constant. So you will take that out. And derivative of x to the power 4. What is derivative of x to the power 4? It is 4 into x raised to 4 minus 1. So 5 into 4, that is 20. 20 x raised to 3. That means what we have got? Second order derivative of y. Y means what? X raised to 5. 5. It is coming as 20 x raised to 3. So this is the answer. So first or second order derivative, if you want to find out, you first find out the first order derivative. And then you here we got the first order derivative as 5x raised to 4. Yes. Hello.
वापस एक्सप्लेन करूंगी मैम.
Yes, yes. Once again, I am explaining. To find the second order derivative, you have to first find the first order derivative. Okay. So y is x raised to 5. Find its first order derivative. That is dy by dx. Y is x raised to 5. What is the derivative of x raised to 5? It is 5 into x raised to 5 minus 1. That is 5 into x raised to 4. So this is what we got is first order derivative. If you want the second order, what you have to do? The second order derivative is the derivative of the first order. Correct? So it is the derivative. See here, d by dx of dy by dx. So d by dx of dy by dx is 5x raised to 4. So ये जो फर्स्ट ऑर्डर आया इसको आप वापस से इसका डेरिवेटिव. So derivative of the first order. So derivative of 5x raised to 4. 5 is a constant. It will be taken out. And derivative of x raised to 4 is 4 into x raised to 4 minus 1. That will give you 5 into 4 is 20. And x raised to 4 minus 1 is x cubed. X raised to power 3. So the second order derivative of y, the answer is 20x. Basically, if you want the second order derivative, you take the derivative of the first order. First order derivative 5x raised to 4. इसको वापस इसका derivative निकालो, so you will get the second order. If you want the third order, you take the derivative of the second order. मतलब इसका derivative. Second order आया, इसको वापस derivative लो इसका. That will be the third order. Fourth order निकालना है तो derivative of the third order, like this. But you don't have more than second order. Okay, so I'm not giving you the examples on third order and fourth order. We have only up to second order. Let us take one more example to illustrate, because unless you understand that, I cannot proceed further. Let y is equal to e raised to x. Find the second order derivative. Find second order derivative of y. Okay. So remember, whenever you have to find second order derivative, you have to first find first order derivative. Find the first order derivative. What is y? Y is e raised to x. What is the derivative of e raised to x? It is same as e raised to x. I have already given you this formula. Derivative of e raised to x is same as e raised to x. So we got the first order derivative of this function y equal to e raised to x as e raised to x. Now what do you want? We want second order derivative. As per our definition, what is the second order derivative? It is the derivative of the first order. Correct? So you take the derivative of the first order. What is the first order we got? E raised to x. So derivative of e raised to x, which is same as e raised to x. That means what we have understood? The second order derivative of e raised to x is also e raised to x. In fact, all the order derivative of this function is same as e raised to x. Okay? I hope you have understood. Let us take one more problem. Let y is equal to x square plus x. Find the second order derivative. Find second order derivative of y. Okay. So as I told you, to find the second order derivative, first you have to find the first order derivative. So let us find out the first order derivative of y. What is your y? Y is this 2x square plus x. And you know how to find out the derivative of this. It is first you have to apply the addition rule, correct? What is the addition rule says? Take the derivative of 2x square plus derivative of x. That is what our formula for derivative of addition, no? Derivative of u plus v क्या होता है? Derivative of u plus derivative of v. That is what I am doing here. Derivative of 2x square plus x is derivative of 2x square, that is by u, and derivative of x. Okay. Now what is derivative of 2x square? I am applying the second rule, that is derivative of k times u, scalar multiplication. So k is taken out and we take the derivative of u. So here 2 will be taken out into derivative of x square. And here derivative of x is nothing but 1. What is derivative of x square? It is 2x. So you will get 4x plus 1. Okay. Once again, what is derivative of y? Y means 2x square plus x. So that is derivative of 2x square plus derivative of x. I am applying this formula, this rule. Derivative of the sum. This one. Okay. For calculating derivative of 2x square, look at this 2. It's a constant. So I am applying the second rule, derivative of k times u, where k is a constant. So k is taken out into derivative of u. Okay. So k is 2, 2 is taken out, and derivative of, here 2 is taken out and derivative of x square. And you know derivative of x is 1. So derivative of x square is 2x, and this will give me 4x plus 1. Okay. I'm writing here the formula also simultaneously. Okay, rules. So first order derivative is coming as 4x plus 1. Correct? Now I want to find out the second order derivative. What is my formula? The formula to calculate the second order derivative. It is the derivative of the first order. So it is the derivative of the first order. What is the first order derivative I got? 4x plus 1. Correct? No? Okay. So derivative of 4x plus 1. What will be that? It will be derivative of 4x plus derivative of 1. What is derivative of 4x? 4 is taken out because it's a constant. Derivative of x with respect to x, and derivative of 1 is 0 because 1 is a constant. So it is 4, derivative of x with respect to x is 1. So answer will be 4. Okay. So the second order derivative is coming as 4. You can see here nicely. Okay. First order derivative is 4x plus 1. To find the second order derivative, take the derivative of the first order. So derivative of the first order means 4x plus 1. So take the derivative of 4x plus 1, which is nothing but derivative of 4x plus derivative of 1. Derivative of 4x, we are applying this rule, k times u. So 4 is taken out into derivative of x plus derivative of 1, which is 0. 4 into 1, so the answer is 4. So I have taken some 3-4 problems to explain you what is meant by second order derivative and how to calculate it. Okay. Now we will see the step-by-step method to calculate the maxima or minima for a function. Okay. So let us write down the step-by-step method. Write down here procedure find extreme values. Now what is the meaning of extreme values? Extreme means extreme, maxima or minima. There is a common word for that. That is called as the extreme values. That is maxima and minima for a function y equal to fx. Suppose you are given a function y which is a function of x. What is the meaning of that? Y is expressed in terms of x. Okay, that is the meaning of y as a function of x. And we'll see. Mathematically, we write it like this. Y equal to f of x means y depends upon x. जैसे कि y equal to x square is a function of x. So हमारा जो cost function है, it depends upon number of items produced. So C is written in terms of x. Revenue function is written in terms of demand. And profit function also can be written in terms of x, where number of items are produced and sold. Okay. So in general, I'm writing this step. So let me write down this step for a function y, which is a function of x. Okay. So what is my first step? The first step is what? Find derivative of y with respect to x. जो भी function आपको दिया है, उसका आपको पहले derivative निकालना है. That is the first step. Okay. What is the second step? In the second step, we solve the equation dy by dx equal to 0. ये जो यहाँ आपको फर्स्ट ऑर्डर डेरिवेटिव आएगा, उसको आप 0 से इक्वेट करो, you will get a equation. You have to solve that equation. Suppose the solution of this equation is, let x is equal to a be the solution of the equation dy by dx equal to 0. See, because I'm writing a general proof, I've written here x is equal to a is the solution. There can be more than one solution for this equation. If it's a quadratic equation, it will have 2 solutions. If it's a polynomial of degree 3, it will have 3 equations. अगर वो ऐसा equation आता है आपको x minus 4 equal to 0, which is called as a linear equation. x का power 1 है, highest power. तो यहाँ पर x का वैल्यू आता है 4, एक ही सोल्यूशन आएगा. लेकिन अगर आपको ऐसा इक्वेशन आता है लाइक दिस, तो x के 2 वैल्यू आ जाएंगे. x का value 2 and 3. Okay. So it all depends upon how you are getting the equation. If it is a linear equation, then you will have like this, then you will have only one value of x. अगर इस तरह का equation है, तो x के दो value आएंगे. Whatever it is, you have to find out the solutions of this equation dy by dx equal to 0. So that is the third step. What is the second step? What is the third step? In the third step, what we do, this is the most important step. We find the second order derivative of the function at the point x is equal to a. ये जो point यहाँ पर आया है solution, उसके ऊपर आपको second order derivative निकालना है. And this will tell you whether the function has maximum or minimum value. So if this second order derivative at the point x is equal to a, if this derivative is positive, you have to only see the sign. If it is positive, then function has minimum value, has minimum at x is equal to. If the second order derivative is coming as positive, then the function will have minimum value. And what is the minimum value of function? And minimum value is given by y equal to f of a. x की जगह पर a को रखना. And if the second order derivative is coming as negative, then the function will have maximum value. Function has maximum. So it is the sign of the second order derivative which will decide whether the function has maximum or minimum value. Okay, so it will have maximum value at x is equal to a. And what is that maximum value? How will you find out the maximum value? Maximum value will be given by y equal to f of a. Okay, so slightly you will find it slightly confusing, or maybe you can say difficult, but you just follow the step-by-step method and you will get the answer. So no need to worry about it. Okay, so let us now, what we are going to do, let us now find out the maximum or minimum value of some function. When I take the example, no, then you will understand that. Okay, so let me take one example here. So I am taking, let y is equal to say x square minus 10x, okay, plus 50. Suppose this is y function. Find minimum value of f. Find minimum. Find x at which the function is minimum. Find minima of x, you can say. Find the value of x at which the function is minimum. Find x at which y is minimum. At which point the function is taking the minimum value. And also find the minimum value. Also find the minimum value of y. Minimum value of y. So what we will do, as per our step-by-step method, first we will find out the first order derivative of y. That is what is my first step, right? Find dy by dx. So find dy by dx, that means you find the derivative of y. Y is what? X square minus 10x plus 50. Find its derivative. So its derivative is derivative of x square minus derivative of 10x plus derivative of 50. Derivative of x square is 2x, 10 will be taken out, and this is derivative of x. This will be 0 because 50 is a constant. So you will get 2x minus 10. Derivative of x is 1. So first order derivative is coming as 2x minus 10. In the second step, what you do? You solve this equation. dy by dx equal to 0. So dy by dx is 2x minus 10. This is what we got here. 2x minus 10 equal to 0. When you solve this, you will get the value of x as 5. 10 upon 2. So it is 5. So you got x is equal to 5. Now what is the third step? In the third step, we find, this is the second step, we find the second order derivative of y. What is the second order derivative of y? It is the derivative of the first order. What is first order? 2x minus 10. 2x minus 10. Find its derivative. So it is derivative of 2x minus derivative of 10. What is derivative of 2x? It is 2 into derivative of x. And derivative of 10 is 0. So you will get 2. Look at this. Second order derivative is positive. 2 is positive. And therefore, function y equal to, y has which value? Minimum value. Y has minimum at which point x is equal to 5. इस point के ऊपर y का value minimum रहेगा. Look at our step. अगर second order derivative is positive, then the function has minimum. तो हमारा यहाँ पर second order derivative कितना आया है? 2 आया है, which is positive. So the function has minimum at this point. And you can find the minimum value. And minimum value is given by, minimum value is f at y at x is equal to 5. तो उसमें आपको find the minimum value. Minimum value is, in this you put x is equal to 5. 5 square minus 10 into 5 plus 50. So what is that? 25 minus 50 plus 50. That will give you 25. So 25 is the minimum value of the function and it is obtained at x. So this is how we calculate the minimum value. Okay? So we'll do more problems in the next class so that the things will become more clear. Okay? So thank you all. I'll give you the attendance link because of, so